James Webb Space Telescope is known to be a very big step forward taken by NASA to understand the universe and its origins. JWST is the most powerful telescope ever launched into space. Its greatly improved infrared resolution and sensitivity will allow it to view objects too old, distant, and faint for the Hubble Space Telescope. Among some of the main goals of JWST is to examine every phase of cosmic history, from the first luminous glows after the Big Bang to the formation of galaxies, stars, and planets, to the evolution of our solar system. Well, another mystery discovered by the JWST is the discovery of dark matter. To begin today's video, we need to understand what dark matter is. Dark matter is a mysterious, invisible form of matter that is thought to make up about 25% of the known universe, outweighing visible matter by 6 to 1. Still, despite making up a considerable chunk of the universe, it has eluded our understanding since its existence was first suggested by a Swiss-American astronomer known as Fritz Zwicky in 1933. Dark matter is inferred by its observable effects on galaxies, which behave as if they are more massive than the visible matter and energy in them would dictate. Until the discovery of the accelerating expansion of the universe in 1998, which implied some unknown force or energy that was driving that expansion, dubbed dark energy, astronomers thought the gravitational effects of dark matter's added mass would cause the universe's expansion to slow down. Both dark matter and dark energy are dark because they don't appear to interact with light or normal matter, but they also appear to outnumber all that stuff that we can see out there. Scientists estimate 25% of the universe consists of dark matter, and some 75% of dark energy, leaving just 5% for everything else that we see. JWST is optimized to help better characterize exoplanets and search for evidence of life in the atmosphere of worlds around other stars, and it may well provide insights into some of the most esoteric questions in cosmology, helping to better characterize the nature of dark matter and dark energy. While the James Webb Space Telescope cannot directly see dark matter, scientists think that by measuring the effects it has on its surrounding, Webb could answer some major questions about dark matter. This, in turn, would greatly advance our knowledge of the universe at large. JWST is the most powerful space telescope ever launched, with a 6.5-meter diameter primary mirror and the ability to focus on single objects very, very far away. Scientists don't know exactly what dark matter is made of, and they are still working out a way to detect it directly. Currently, scientists are developing such methods with experiments at the Large Hadron Collider, LHC, at CERN, the European Organization for Nuclear Research. Unlike these experiments, Webb won't be able to detect dark matter directly, but it can study its effects on normal visible matter. When it comes to dark matter, this should allow JWST to make use of gravitational lensing, the way the mass of a galaxy bends light from galaxies behind it as the photons pass by the foreground galaxy. By imaging distant galaxies behind closer galaxies, JWST will enable scientists to measure the total mass of the closer galaxies by how much they bend the light from the background galaxies. The difference in the predicted mass of those foreground galaxies and what JWST measures could be the mass of the hidden dark matter around the galaxy. When you observe dark matter, you have to sort of always go in a roundabout way because you can't see it. But Webb does have the capability to try and get at that in new orthogonal ways, looking at the dynamics of galaxies. Klaus Pontoppidan, a project scientist at the Space Telescope Science Institute, said in a news conference, "For example, as a roundabout method of detecting dark matter, astronomers can use existing technologies to measure how much mass is in stars and galaxies. Some of the main evidence for the existence of dark matter is that many galaxies could not exist and move as they do without a large amount of invisible mass." Webb will take extremely sharp images in which researchers will be able to observe disturbances caused by gravitational lensing, pointing them to where the invisible mass is lurking to help astronomers more precisely locate that dark matter. Gravitational lensing is a phenomenon described by Einstein's general theory of relativity. With this phenomenon, when a light beam passes a large mass, it will be slightly deflected as the fabric of space-time is slightly curved by the mass. In imaging distant galaxies, Webb can find these masses and determine what's missing or not observable, which would then likely be dark matter. Webb will be particularly well suited for this type of measurement because its very sharp images will allow very small disturbances to be measured, and because it can see so deep into space, giving it access to many more background galaxies to measure disturbances caused by this gravitational lensing effect. Dark energy was first revealed based on the observations of distant supernova and confirmed in 2003 with measurements of the cosmic microwave background, the afterglow of the Big Bang. Supernova are like lampposts. Space Telescope Science Institute astronomer Adam Rees says they allow us to make measurements of the expansion rate of the universe. Adam Rees was one of the scientists who shared the 2011 Nobel Prize in Physics for the discovery of dark energy, and he says the JWST should allow more precise measurements of supernova, allowing more precise measurements of the expansion of the universe, which in turn relates to dark energy. Limitations of JWST's dark matter and energy studies. One of the limitations of the study of dark matter is that the James Webb Space Telescope is optimized as an infrared telescope for peering deep into the past and outer reaches of the cosmos, a narrow field of view instrument for looking at single objects very closely. That are exactly the qualities you want for imaging the first stars in the universe and studying the atmosphere of distant worlds, but it's not the best tool for studying dark matter and dark energy. According to Adam Rees, telescopes that are optimized to study dark energy try to observe a large fraction of the sky. The way we learn about it and measure it is by adding up its consequences over a lot of space or a lot of volumes. The upcoming Nancy Grace Roman telescope, expected to launch in 2027, will by contrast sport a wild field of view capable of imaging wide swaths of sky, which is exactly what you need to measure the effects of mysterious forces on large structures or portions of the universe. It's sort of like saying, can I measure gravity using a grain of sand? Yeah, but you'd be better off using a cannonball, Rees says. JWST and Nancy Grace Roman could, however, work together once Roman is deployed. Roman may identify hundreds of distant supernova, for instance, but JWST will be the one to make the most precise measurements of those distant lampposts possible. Also, the James Webb Space Telescope will observe many statistics of galaxy evolution, and scientists can compare these observations to theories of the role that dark matter played in that process, leading to some understanding of the amount and nature of the dark matter in galaxies. Let us know what you think about the discovery by the James Webb Space Telescope of dark matter down in the comments section. Remember to leave a like and subscribe to this channel for more interesting videos like this. Turn on your post notifications and stay tuned so you don't miss any updates from us. Until next time, stay safe.